This is a lesson for Chapter 5, Section 6, which deals with parallel and perpendicular lines. And so what we've seen in the past, especially when we were graphing, we graphed lines that were parallel, and what we ended up noticing is that the parallel lines always had the same exact slope, and that's what it says here. Parallel lines have the same slope, but different y-intercepts. So you can see how the red and the blue line are both parallel because their slope is 1 to 2. So I'm going up 1 space over 2 space each time. Same thing here. On this line, you see how you go up 1 space over 2 space each time. And so when we're looking at trying to figure out or write equations that are parallel, we first can find out what that slope is, or we know what that slope is because we know it's the same. And so that's what they're going to give us here. So they're going to give us a point, and they're going to say, well, this line that we want you to come up with is going to be parallel to another line. And here it is. It's parallel to y equals 2/3 x minus 1. What equation represents that line in slope-intercept form? So the first thing is to pull out what the slope of the line is. So here the slope of this line is 2/3. So that means the parallel slope is going to also be 2/3. So now we know what the slope is, and we know this point. And so we can use point slope. Point slope goes this way. Y minus y1 equals m times x minus x1. So we're going to take the point that we have and substitute it in for y1 and x1. So y minus 5 equals, and that'll use that 2/3 times by x minus 12. And I'm getting the 12 from this point here. That's my x1, and here's my y1 value. And so I distribute the 2/3 over that subtraction, and I'm left with y minus 5 equals 2/3 x. And then here the 3 goes into 12 4 times, multiplying across. 4 times 2 makes 8, so minus 8. And then all I have to do is add the 5, and I'll get the answer. So here my slope-intercept form that is parallel to the given line, passes through the given point, is y equals 2/3 x minus 3. Minus 3 because subtraction here, because they're opposite in sign, more negatives and positives. Well, this problem's a little bit tougher because the slope's not in front of us right away. So sometimes we have to do some work to get y by itself. So remember, we're trying to put it in the slope-intercept form, this form here, y equals mx plus b, because if we have y by itself, this is the number we're looking for, that slope. And so now we've got it. Y equals negative 3x plus 5. So I know my slope in this case is going to end up being negative 3. That's the slope I'm going to end up using there. And then I take the point, negative 9, 3, and plug it into my point slope formula. Y minus y1 equals m times by x minus x1. And so I do some work. Y minus, and then I've got 3 equals, and then I've got the slope is negative 3 times by x minus negative 9. And that minus negative, it just makes a plus positive. I distribute, and I've got now y minus 3. So y minus 3 equals negative 3x minus 27, because negative 3 times 9 makes negative 27. And then I just have to add the 3 to both sides, and we'll have our answer. So y equals negative 3x, and then minus 24. So that's the equation in slope-intercept form. That is parallel to the given line passing through the given point. So that's one type. Let's take a look at the other type that we end up seeing, and it's slopes of perpendicular lines. So here it says that two non-vertical lines are perpendicular when their product is negative 1. So if we had a vertical line just as x equals a number, maybe like x equals a, and then a horizontal line would be perpendicular when it's just y equals some other number, maybe like b in this case. And so, or it could have been a as well. But those lines are perpendicular, so here they're talking about non-vertical lines. So the only time a vertical line is perpendicular to another one is when the other is horizontal. So they talk about this concept where you multiply the slopes to make negative 1. So here's an example. So the graph of 1/2 has a slope of 1/2. Negative 2x plus 1 is the slope of negative 2. If you multiply them, you get negative 1. That's true. And now the other way you can think of it is this. If I had a slope of 1/2, the perpendicular equation, or the perpendicular slope, we said, so there's my symbol for perpendicular, upside down t. M stands for slope, is negative 2 over 1. So you can see that another way to think about it is they are opposite in sign, and that's why they end up making a negative, and reciprocal. And so that's where the 1 comes in, because when we multiply, the 2's in this case cancel out, because we're multiplying reciprocals. So opposite sign and reciprocal is another way to think of what the perpendicular slope will be. So here it says we want to draw or write an equation on a line that passes through this point. It's perpendicular to this equation. So let's mine out the slope here, and it's right in front of us. 2 is the slope. So our perpendicular slope will be negative 1/2. You see, if I multiply 2 times by negative 1/2, I get negative 1. Just as they multiplied 1/2 by negative 2, they got negative 1. So I know this is the correct slope. Now I'm going to use the point in point slope. Y minus y1 equals m times x minus x1. So I go ahead and substitute in y minus 8 equals negative 1/2 times by x minus 1. So I can go ahead and distribute, and I'm left with y minus 8 equals negative 1/2 x plus 1/2. So from this point I just need to add 8 to all sides, and when I add 8 to 1/2, we're left with y equals negative 1/2 x plus 8.5. So that would be the equation of that line that passes through this point and is perpendicular to the given line. So it's a little bit tougher one here where it doesn't look like it's in that slope-intercept form, but really our slope is this number right here. This is in point slope. Point slope is that y minus y1 equals m times x minus x1. So right there, there's our slope we're going to use. So we're going to use that slope to help us find the perpendicular slope. Negative 2/3 is the slope we're given. The perpendicular slope, though, is the opposite sign and reciprocal. So it's going to be positive 3 over 2. And you can see how negative 2/3 times by 3/2, the 2's and the 3's will cancel, just left with a negative sign, which makes negative 1. So the product is negative 1 when we're multiplying perpendicular slopes. So we're going to use this slope here, use the point in our point slope formula. Y minus y1 equals m times by x minus x1. So I substitute y minus 3 equals, and then I've got my slope I'm using of 3/2 times by x minus negative 8. And so when we go ahead and distribute, again, minus negative makes a plus positive there. Y minus 3 equals 3/2 x, and then the 2 goes into 8 4 times. Multiplying across gives me positive 12. So from this point, all I have to do is add the 3 to all sides, and we'll have our answer. So it's going to be y equals 3/2 x plus 15. And that's the equation that is perpendicular to the given line, and then it passes through this given point. So those are problems that you're going to see on tonight's homework. Good luck.